Ever wonder what the real difference is between a cool AI demo you see online and a professional grade application that a business can actually bet on? It's not just about having a giant, powerful model. Nope, it's about a very specific stack of technologies. Technologies designed to make AI knowledgeable, helpful, and most importantly, safe. And today, we're going to break down that exact stack for you.
All right, here's our game plan. We're going to follow the exact journey you take to build a sophisticated AI in the real world. We'll start with the core architecture, then hit the major roadblocks you'd encounter, and finally, look at the brilliant solutions that make it all work.
So to really get a grip on how we ended up with models like GPT-4, we have to jump in our time machine and go back to 2017. Because that's when a single research paper dropped that, well, it completely changed everything for AI. See, before 2017, the main way we taught machines to understand language was with models called RNNs and LSTMs. And they were pretty smart for their time, but they have this one huge flaw. They had to read text word by word by word, just like a person reading a book. This created this massive bottleneck, and worse, they had a terrible memory. By the time they got to the end of a long paragraph, they'd pretty much forgotten what the beginning was all about.
And this is what made the transformer architecture such a total game changer. Instead of reading word by word, transformers can basically look at the entire sentence, or even a whole document all at the same time. This ability to process everything in parallel wasn't just about speed, although it made things way faster. The real breakthrough was that it allowed the model to finally see the connections between all the words, no matter how far apart they were.
So, what's the secret sauce behind this? It's something called the attention mechanism. And it's exactly what it sounds like. It lets the model pay attention to the most important words for context. You know, like if you have a sentence, the delivery driver handed over the package and he smiled. The attention mechanism is what helps the model know that he is the driver, not the package. It creates this strong connection, letting the model focus on what's truly relevant.
And the impact? Oh, it was absolutely astronomical. We're talking over 173,000 citations for this one paper. That's insane. It literally laid the foundation for every single large language model we talk about today. BERT, GPT, all of them. This wasn't just a step forward, it was the spark that lit the whole bonfire of the modern AI boom.
Okay, so this new transformer architecture was incredible. But as soon as these models got really powerful and started being used out in the wild, a huge and very embarrassing problem started popping up everywhere.
And you've seen this, I know you have. You ask a chatbot a simple question, and it comes back with this perfectly worded, super confident-sounding answer that is just completely and totally wrong. Or maybe it gives you information that's like 5 years old. So what is going on here?
Yeah, this thing has a name. It's called hallucination. And the most important thing to understand is that it's not really a bug, it's just a direct consequence of how these models work. See, LLMs are just incredible prediction machines. They're trained to predict the next most likely word based on the patterns they saw in a fixed, static pile of data. They have no concept of truth and no access to what's happening in the world right now.
So that's the big question, right? How on earth do you build a real, reliable application on top of a technology that kind of just makes stuff up? Well, you can't retrain the model every 5 minutes. That's crazy expensive. Instead, you do something much smarter. You give it an open book exam. And the technique for that is called Retrieval-Augmented Generation, or as everyone calls it, RAG.
And this analogy from K2View just hits the nail on the head. Think about it. An LLM by itself is like a stock trader who has only read history books about the market. They've got tons of general knowledge, for sure. But RAG is like handing that trader a live Bloomberg terminal with real-time market data and your company's private research. All of a sudden, they can make much, much smarter decisions.
The way RAG works is actually pretty simple, and it's brilliant. So a user asks a question. First, the system retrieves relevant documents from your own private, trusted knowledge base. Then, it augments the user's original question by stuffing that new information right into the prompt. And finally, it sends that whole supercharged prompt to the LLM to generate an answer that's now grounded in actual facts.
But here's where we separate the basic demos from the production-ready systems. You can't just point RAG at a folder full of PDFs and call it a day. No way. You have to be really smart about how you prepare or chunk that data. And it's a whole science, from simple fixed-size chunks at level 1 all the way up to level 5 where you're actually using another AI just to figure out the best way to slice up your documents. Getting this part right is absolutely critical.
And hey, don't just take my word for it. This isn't some niche, nerdy trick anymore. The big industry analysts like Gartner are literally telling CIOs and business leaders that they need to be prioritizing investments in RAG. They see it as a non-negotiable part of getting real, trustworthy value out of generative AI.
Okay, awesome. So RAG gives our AI the facts. It solves the knowledge problem. So we're done, right? Ship it. Well, not so fast. Because it turns out, just because an AI is factually correct, that doesn't mean it's helpful or safe or even polite. And this brings us to the next massive challenge, the alignment problem.
What we need now is a way to fine-tune the model's behavior, not its knowledge, but its personality, its style, its tone, whether it follows our safety rules. And the main way we do this is with a technique called reinforcement learning from human feedback, or RLHF. You can basically think of it as teaching the AI good manners.
And a really great way to get your head around this is with a chess analogy. There are two main flavors. The first is on-policy learning. This is like the AI is actively playing chess games and a coach is giving it feedback in real time. Then you have off-policy learning. This is more like the AI is just studying a massive library of past games, learning to copy the good moves and avoid the bad ones without ever playing itself.
When you look under the hood of a full-blown RLHF system, it's not just one model. It's like a whole team working together. You've got the actor. That's your main LLM, the chess player. Then there's the critic, who's like the coach, giving feedback on every single move. The reward model acts as the referee, giving a final score to the whole conversation. And you even have a reference model, which is like the original playbook, making sure the player doesn't get too creative and forget the fundamentals.
All right, so let's recap. We have the transformer architecture as our powerful engine, we have RAG to give it high-quality fuel, and we have RLHF to steer it in the right direction. So now, let's tie it all together and talk about what this means for building professional AI and for your career.
Look, building a production-grade RAG system is a real engineering discipline. It's not just about plugging in a database. You have to obsess over the quality of your knowledge source. You need to use sophisticated hybrid search methods. You've got to re-rank and filter your results for maximum relevance. And you have to constantly be experimenting. Mastering these details, that's what makes a system truly reliable.
And let me tell you, the demand for people who actually know how to do this stuff is just exploding. This isn't a research topic anymore. We're seeing the big cloud players like AWS and Google launch professional certifications focused specifically on building and deploying these production-ready AI solutions. That's a huge signal about where the job market is going.
And these skills are being put to work to solve real business problems today in every department you can think of. We're talking super smart chatbots for customer service, targeted recommendation engines for sales and marketing, even systems that automatically handle complex compliance requests. The value is already there, and it's massive.
So when you put it all together, this is the new gold standard. Transformers are the powerful engine, RAG is the high-octane, trusted fuel, and RLHF is the steering wheel that keeps it on the road. This trifecta, this is the formula for building AI applications that you can actually rely on.
And that brings us to the end of this explainer. We've figured out how to make AI knowledgeable with RAG and how to make it aligned with RLHF. But as these systems get even smarter, even more capable, it leaves us with one heck of a question. What's the next big problem we're going to have to solve? Thanks so much for watching.